Okay, guys, we are back on the track, and we are just starting the last session today, but not the least. And I'm together with Marek Dominiak, who is CTO, hands-on architect, team leader, trainer at Spark Byte Solutions, and also Train Tech. So multiple roles, so also multiple backgrounds. And Marek delivered for us a presentation under the title Back to the Future Strategies for Dealing with Date and Time in Test and Production Code. As always, the chat is for you, so please post a question to Marek during his presentation, and at the end we'll manage to do some short Q&A session. So Marek, the stage is yours.
Okay. Hello, everyone. It's pretty light today. However, it's unfortunately we can't move back to the past or to the future in in real life. However, we can do that in software. So this presentation is all about that. So thank you, Mateusz, for telling a little bit about me. We have not so much time, so let's start with agenda over here. So this will just flow from the beginning to the end, where we would like to see what's the most common problem that we probably most of us of you have in your code bases that disable us from cool things or inability to test some production code. So first of all, we will take a look at this, and we will see all the consequences, problems, and potential solutions, so-called solutions that we try to apply when we stumble upon those problems. Then we will jump to date and time in test code, and we will see how we can use those strategies I will show to test complex scenarios. And later on, this will be probably some new things for many of you. I will show some simple tools that you can ensure some common rules in the code bases. Probably some of you know those tools, some not. And later on it will be Q&A. So let's just start. So usually I would ask this question, so who has experienced issues with date and time in production or test code? By the way, like when I thought I will start this presentation by listing all problems I stumble upon during my years of experience that were related to date and time. But when I reached point number 14, I just moved this slide to the very end of the presentation because it would just swallow the whole presentation. So probably you will find your problems over there, and most of those problems will be solved by using the tools I will show now. Now, let's start with our common ways of creating dates in our code base. So usually when we need a date or some instant or local date time in our code base, we will use one of those solutions. New date, probably not so often anymore. However, in some older code bases, you will still see it. Or maybe those you will use. Maybe you will use local date time. Maybe you will use clock directly or indirectly. And this is most probably what you will see throughout your code base. And there are some certain problems with this. And to explain this problem, we need to jump into some more real-like domain problem. So let's talk about this example. So let's imagine we have to implement and we work with the system that delivers, offers some enrollments to users to some courses, and those users can take those courses. So on the timeline and time is really important in those cases. So first of all, user can be enrolled, and later on we can make some rules that enrollment is available from some certain period, certain point in time in the future. Then user starts enrollment, then possibly completes it after some time, and then it as well just makes this enrollment or this course valid for this user for a number for a certain period of time. So this is kind of most of you will have a similar let's say problems or use cases in your projects. So this should be really similar, feeling really like at home. Now the quiz. So tell me, what is the difference between runs of the code on the left and on the right side? Runs, I'm not saying whether the code is identical. So obviously you can't answer to me directly, but so I will spill the beans over here. So the code is identical. However, there is a difference between runs of the code on the left and the right. What it is? The code is identical, JVM is identical, everything is identical, but there is one thing, that those two pieces of code can run at different time. So they can produce different results. But looking at this code over here, can you really see it? I doubt it's impossible. You don't know. If someone will ask you, hey, we have a bug in enrollment.start method, can you just fix it? Yes, it will take 1 hour. And then you will discover that it's not so, it's trickier than you thought so, because enrollment.start will look like this. It's very simple code. In line 4, we create an instant now, and then we will just use this now to check whether we can start this enrollment because it was available, like we are comparing this together with available from date. However, this looks very innocent. However, it's not. This call over here is essentially a Pandora box for you. This is what strips away all of your control over the time and date in your code base and have some consequences. The first consequence is that when we will come back to this little slide, we will see that the code on the left, when running on 20th of September, there will fail, and when run on 26th of September, it will work. That's a difference. So essentially, this code that we wrote, this code over here, instant.now, inside our domain objects, have some consequences. And there is a consequence, a problem related to this, that we have a dependency on the system clock. Now the very big question appears in front of us. So how can we reliably test scenarios in the past and in the future if we can't control the time? So we have some solutions, and maybe some of those you will see or remember doing something like this in your code bases. Now we are talking about a little bit of testing. We have some domain code. Now we would like to test it. And then we will have some reflections. We will hack our domain objects. So I believe each time I gave this presentation, I saw many hands inside the company, outside the company as well. Many hands that went up when, obviously we are hacking our domain objects. But this is not good. We are essentially skipping some important business rules when testing. That's really bad. Another solution, who saw something like that? We are sleeping in the code, and so we are sleeping in the code just to move the clock a little bit more. Recently, I found this beauty. Please don't use it. When someone mentioned that, oh wow, this is awesome, we will not wait milliseconds or a second, we will wait nanosecond. It's still only a hack. It will only work in some very specific cases if you are working with instance. It's not a solution at all. There are some other ways what we can do. So obviously we can use PowerMock, or we can use Mockito from version 3.4.0. There is a way of you being able to mock final and static invocations, and you can control things in an ugly way. However, if you will take a look at the documentation of those, they say that this most probably means that your code sucks in production. They obviously say it in a little bit nicer way. Another solutions that we usually have, we can just, oh hey, we have some tests that sometimes fail, sometimes not. Let's delete this flickering test. We can as well hack our domain objects, as I mentioned, or this one I like the most. So I believe few of you to test certain scenarios in your production or test code had to move the system clock. I had to do that, at least 10 years ago I did that, and then I learned better ways. So now the whole idea over here, I would really like to point this out, that you can't test or simulate the whole process that can take hours or weeks in their real life without hacking domain object if you write your code and create dates in your domain objects like I showed you before. And so there are some hard or impossible to test scenarios. For example, I like this one. Online exam must take no longer than 2 hours, but each question should take minimum 12 seconds. So for 100 questions, exam should take minimum 20 minutes. And this is for proctoring. Just essentially, we would like to ensure that no one will hack our course or do too fast courses. So there are as well, and to leave with the last thing about beating this kind of writing this code in this way, is that we violate the principle of the least surprise. So essentially, we take a look at this piece of code and we say, oh yes, this bug will take 1 hour. And then we go inside and then we see that we have a stack trace of 7 layers underneath. And then we discover that underneath someone created instant.now, just 7 layers above. So now have a fun testing and refactoring this code. Essentially, I had to do this years ago, and essentially I hated the guy who wrote this code. And it was me, so I had to refactor this. So anyway, now, if you must remember one thing from this presentation, is this: time is a dependency in our code. So now we will work with this premise and we will see how it shapes our production code. So if time is a dependency in our code and we use a Spring, for example, so we have dependency injection and we would like to have application-wide control of time. So essentially, you should have only one place in your module service project that really creates dates, essentially a singleton. And we will use a clock for it. So clock was introduced in Java 1.8, Java 8. And what it is, it's essentially a factory for instance. So just it gives you abstraction over a system clock, meaning you can manipulate the time or give just different implementations of clock for different purposes. And if you would like to use clock, so obviously we need to create a clock somehow. So, and then we have a factor of creating those clocks. So in the line first, over here, we have a clock.instant, so which is system UTC. We can as well create another time zones over here, or we can create a fixed clock, which always will return us exactly the same date and time or instant, if you will. Now, we will use this clock and we will make it explicit in the code base. And now we are talking about production code. So back to our previous piece of code, we will do this. We will essentially put explicit parameter when we would like to create the dates in our domain object. So now we pass object clock to enrollment started, and it feels a bit ugly. Why this clock is over there? However, this one simple trick gives you all the control you need. It's essentially dependency. We know that time is dependency, so we should be able to control it. To control it, we need to have a handle on it. And to have a handle on it gives us this way that now we can create instance based on this clock, which means the clock and implementation of it controls it. And this small trick gives you all the control you need. Now, to configure it in Spring, we need only this one class. It's a singleton. It's only for production code, because for test we would like to use a different implementations of clock. We will just work with them. And for keeping the things very easy and understandable, we should use a system UTC. So no, it's just the easiest thing ever in our code base. Let's just keep the thing simple. Let's use UTC 0. Now, how we will use this clock? We will just inject it. So if we have a service or a handler, we inject our clock like another Spring dependency. And then after we find our enrollment somewhere from repository, we would like to start this enrollment, we will pass it a clock. That's it, nothing else. This is the whole point in the production code. Very simple, very easy way of doing this. And this is a reminder. So essentially inside, we just pass this clock, and this clock over here is essentially a Spring Bean. And by the way, there is a official documentation from Oracle. I usually don't use it too much. However, in this case, I really like this piece. So they say that this is the way you should create dates and how you should use clocks in your application. You should just you should just inject it somewhere, and then you use it somewhere else. That's it. So this is official documentation, just should be a little bit more known. So the last notes about production code: we inject clock only in Spring Beans, and domain object should be given the clock instance from outside. Now let's switch gears. Let's move to the test code, because that's what was hitting us before. Now let's see what can we do with this. For sake of this presentation, and let's just make this very simple definition. We will have fast test, and I will call them as well unit test, and slow test will be those that touch IO. Those are essentially flavors or integration tests. They are much slower. So those will be Spring tests. Let's talk about fast tests, unit tests. So if we would like to manipulate test date and time in unit tests, so we can use clock fixed. And this is very simple thing. So clock fixed, it's giving you a clock, and this clock is always will return exactly the same instant. This is very easy to use. But sometimes you would like to manipulate it and mutate the clock. So then you need to implementation of a clock that gives you that. So if you use Spock, you are in heaven, because Spock gives you this out of the box. This is good. So if you use Spock, you have implementation of mutable clock that is perfect, because if you initiate it, then it stays exactly as you set it. And if you would like to change it, you need to tell it to change it, so you can control the time. If you use JUnit or TestNG, unfortunately, you need to create your own mutable clock. There are sources of together with this presentation. There will be a GitHub link. You can just see very simple implementation that I provided as well. It's very simple thing, and you can just use it or borrow it, and then you have your mutable clock as well. Now, we will use, when you use Spock, and we can have a very simple trait, which is kind of an abstract class in Java, or that will allow us to manipulate the clocks from it will have a clock that uses mutable clock. We will have additionally 3 methods. Adjust clock is very simple. We create a clock, and then we would like to move it for 2 days to the past or to the future, and we can use it by setting adjust clock. Set clock to, we would like to set clock to 1st of January 2000. That's it. And then we have as well some additional methods. The most important in line 15, just we would like to create an instance that this mutable clock gives us. How can we use it? We create very simple tests. Now, instead of creating, we need to use this clock that's mutable. And now in line 8, we have option to manipulate the date and time. So we adjust the clock with a day ahead, and then we start enrollment. So we can now test our domain code without any hacking. Perfect. That's what we really need. we can do better. Now this is more like Saga. Now we would like to make a very complicated test case that spans many days, many different phases. So we have like initial enrollment created, started, some days passes, and then be completed. Perfect. By the way, so if you won't use clock, what will happen over here? Tell me, will this test fail or not? Obviously, you can't answer me, but the thing is that it will always fail because instant is just nanoseconds. So nanoseconds, what does is essentially, if your computer is not fast enough, it will always be a little bit late. So this kind of thing we see in our tests and makes them fail. What it means, it leads to flickering test. However, if we will change and use mutable clock, we can create instance in the same code base, and unless we move the clock, we can make the test pass. So we can have more deterministic builds and tests. So having this in mind, with unit tests, we can do this. We can do moving to the future and to the past, exactly like as Doc and Marty. And this piece of code essentially prints out exactly this code you see on the right side. So essentially, you are the god of the date and time. This is perfect. But you say, okay, Marek, this is only just unit test. I have the fast Spring tests. So what can we do? All right, let's talk about Spring tests, IO tests, slow tests, integration tests. So if we don't really care about the date and time, or we just need to create some, for the sake of tests, some instant, we can just use clock fixed. That's fine. However, if you use a Spock, again, you can use mutable clock. Perfect. And the same idea with JUnit. If you use JUnit, you can borrow the implementation from which I provided, or if you have Spock on the code base, you can as well use this mutable clock in JUnit that we do in parts of our projects. For example, in my case, we have project that uses both JUnit and Spock, so we kind of have this without any issue. And about this last thing is that we will just come in a second. So the configuration for Spring for tests will look like this. This is a singleton that takes over this is located in the test code. It's a mutable clock with a time zone UTC, and it's a singleton. So essentially now you have a mutable clock in your application in tests in one place, and you will be able to manipulate the date and time. How will you use it? Again, this is a Spring Boot test only, very simple Spring Boot test that we inject our handler and we use our clock. And this is a normal injection now. And now we set the clock to a very specific instant. We are now in 10th of September. And then we say we didn't move the time. So now if we would like to try to start the enrollment, it will fail. That's okay, because nothing happened. We didn't move the time. But another test. Now this test is different by only this line of code over here. We move to the future by 2 days. And then we start our enrollment. And then we see that enrollment is essentially started. And this is Spring Bean. Those are essentially fast tests, slow tests. So, and we have all the control we need. So now we can create a very complicated scenarios, and we can manipulate date and time however we want. The only reminder is that we need to have the time control in our production code with the Spring Beans. Let's take a look at the trait for integration test. This one looks almost identical as to the one for unit test. The difference is that we don't create mutable clock by ourselves, we auto-wire it from Spring. That's the one auto-wire configuration we showed before. There is one more caveat when we, because we work with the Spring, and Spring essentially means that there is application context and there is only one single clock. And because many tests share the same application context, it means that the clock, the one test can manipulate the clock of another. So what we can do, we can create a test execution listener that will be resetting the clock to something what we would like. For example, the real time. So we would like to avoid cases where we run our test suite and we see that we get some weird dates, maybe in the future, maybe in the past, and they vary between the runs. So essentially, and it still should work. However, this listener will allow us to make our life easier. Again, we have three methods: adjust clock, 2 days plus, minus 2 days, set clock to, set the clock to 1st of January 2000 or maybe 2099, and instant if you would like to create one. Now we can do the same. Back to the future integration test. This is essentially a Spring Boot test that does exactly the same thing as we did before, and it uses as well now clock that is a Spring Bean that we created for tests. This gives us all the options we need for testing complicated scenarios, and I believe many of you have complicated scenarios in your code bases. So now for slow test, we need to remember about resetting our clock. You can, if you use JUnit, you can use before each, or you can use test execution listener from Spring. And by the way, there is the code for this listener is uploaded as well to GitHub repository. You will see the link at the end of the presentation. So all this code you saw in this presentation is in the code base over there, and you can play with this. But now you will say, okay, but Marek, this is all nice and fine. But however, I know that Piotr, Agnieszka, or whoever I work with will go and create those new date instant now, and no one will be able to just ensure that we have this code base that essentially follows just follows the rule that we use the clock from outside and we don't create our own dates inside our object. But there is this beautiful, very beautiful framework or a library that's called ArchUnit. By the way, if you haven't read about this, it's very simple, powerful, and it can be used in various ways to ensure architecture rules. And there is this rule over here is essentially saying that no classes should call local date now method, or for example, call constructor of a date class, or instant.now, and so on and so forth. So essentially, this class will fail the test whenever someone will breach or bypass this rule. And by the way, you can produce a link because in production code, we use clock to create dates. And here you can put the link to your wiki, Confluence, or whatever you would like to. And this one simple test essentially ensures the rule in the code base. This is good. Maybe it will take some days of refactoring to get until then. However, this is very important. So if you haven't heard about ArchUnit, you will gain much of it from it. And by the way, when I got this idea about this, I thought it's so beautiful. It's 10 lines of code and saved me hours of code reviews and back and forth between developers and trying to explain and explain and explain the same things all over again. It's really beautiful in my heart. Now, because we have 2 minutes more, so I will tell you about sometimes when we have slow tests, we have a real case where our integration test needs to call some payment provider. And it's essentially real service like Stripe. We have this case. So the payment provider at some point will do something that our integration test has to check. And we have no idea or no control of how can we ensure or know that something happens. So in those cases, we should, when you really need to wait in your test until something asynchronous happens in your tests, you should use a wait utility. And awaitility can work like this. So we just say await, another cool library, at most 1 minute, and every second try to ensure that we can download this invoice from Stripe and ensure that the contents are proper. So this method over here, will return false or true. If it will say false 59 times, but on this it will fit on the 60th attempt and it will pass, the test will pass. It's really slow test. However, here the main point is that we try to test the real integration with some external system. So when you can use awaitility when you need to just test some real payment providers integration, SMTP servers, Elasticsearch, messaging systems, essentially anything asynchronous that is outside your control. So the thing is that I would like to just coming back to ArchUnit, just would like to show you that this is essentially the real code over here. And what I did over in the code base you will have access to, I created a class where I create, for example, new date directly in just production code over here. Now there's a simple test. I will run it, and you can see how fast it will be. It's essentially a unit test. It fails in no time and essentially says what I showed you before, that there is this method over there calls constructor Java new date, and you can press over here. And then you have information that you shouldn't do this because there should be a link to your Wikipedia, wiki or Confluence. Just think about this next time when you will try to talk with your colleagues. Now, I commented out this code. So now essentially I fixed the issues. We don't have usages of this in our production code. Now, the test passes. I really wanted to show it to you to inspire you to just use this very simple strategy over here. So if you need to remember one thing from this presentation is that time is a dependency, and take a good care of it. There are some links to my LinkedIn. You're welcome to join me there. And there is a link to GitHub. You can see all of those sources over there. And thank you for watching. And now we have, I think, 2 minutes for questions, if there are any.
That's right, Marek. Thank you very much for your presentation. We have a few minutes for Q&A session, and I will look at our chat if there are any questions. I don't see any. So maybe let's give a half of a minute for the participants to write down the question on the chat. And I encourage all of you to rate Marek's presentation using QR code that you see on a screen, or using the stars that you have below the video player. Okay, I'm checking once again our chat if we have any questions. I don't see anyone. So Marek, you have a very amazing presentation that everything was clear and no one has any question to it.
This is a nth time I give this presentation, so hopefully it was very clear. Or on the contrary, it's a Friday about 6 p.m. or 5 p.m. or whatever it is in your current time zone, and it's really hard to follow on some more complicated scenarios. However, just remember 2 things: ArchUnit, awaitility, and that time is dependence, and make it explicit in your code. And yeah, there are some few slides afterwards, but essentially for those people who would like to, who are hoping for some information about time zones or more deterministic CI runs, storing dates or date formats, or fun issues with date and time, this is what I had to move to and not talk, because we wouldn't be able to fit into this presentation. However, those slides will be there and you can take a look at those slides as well.
That's right. So thank you very much once again, Marek, for your presentation. Thank you all of you for participating in this session and for a whole day of JavaConf 2023. That will be everything for today, what we prepared for you. I'm very glad that I could be a part of this conference. And once again, thank you very much for participating of today online days, and see you tomorrow on on-site day in Warsaw on University of Technology in Warsaw. So see you tomorrow.